The giant leap for mankind could have been the hoax of the century.
That's one small step for man.
There remains much to discover about the moon, particularly its mysterious dark side, which has largely remained shrouded in secrecy. However, recent revelations from Russia have shed light on some startling details concerning activities on the hidden side of Earth's satellite. So, in today's video, we will delve into the revelations made by Russia about their covert mission to explore the far side of the moon, breaking the silence surrounding this enigmatic lunar territory. The far side of the moon has always held a sense of intrigue. It perpetually remains hidden from Earth's view, earning it the somewhat misleading moniker, the dark side, even though sunlight does reach its surface. Exploring this region is a challenge, as it requires a spaceship journey to reach. However, the true mysteries of the moon are not limited to its far side. They lie at the poles, where the sun's light barely grazes the horizon. These unique lighting conditions create special zones known as permanently shadowed regions, where hundreds of craters at the north and south poles have never received direct sunlight or warmth from the sun. These areas have remained dark and extremely cold for billions of years. While astronauts have touched the moon's powdery surface, and space probes have meticulously mapped its terrain from above, no one has yet ventured into the depths of these pitch-black craters. Astronomers anticipate that with the right tools, they may uncover something remarkable by peering inside these enigmatic craters. However, over the past 5 decades, scientists have gradually unveiled some of the secrets of the moon's dark side. Russian scientists in particular have been probing the far side of the moon and have made an unexpected discovery. They have found a sizable chunk of metal buried deep within an even larger crater, and they believe that studying this metal could provide insights into unresolved mysteries surrounding the formation of our solar system. Our first comprehensive view of the moon's far side was obtained approximately 6 decades ago when US and Soviet probes captured the initial images. Among these images, scientists discovered an enormous crater located near the moon's south pole, now known as the South Pole Aitken Basin. This crater is extraordinary in both size and age, earning its reputation as the largest and oldest crater found within the entire solar system. Measuring approximately 2,500 kilometers in diameter and boasting a depth of 12 kilometers, this basin formed as a result of a colossal asteroid impact around 4 billion years ago. The impact's force would have been roughly 1,000 times greater than the asteroid responsible for the extinction of the dinosaurs. However, the South Pole Aitken crater isn't just notable for its immense dimensions. Recent surveys employing advanced instruments and technologies have unveiled the lunar surface's structure in unprecedented detail. For instance, the Lunar Orbiter Laser Altimeter, LOLA, situated on the Lunar Reconnaissance Orbiter, has provided highly precise measurements of the moon's topography. Additionally, NASA's Gravity Recovery and Interior Laboratory, GRAIL mission, has assessed gravity's strength across the lunar surface. When combining the data from these two sources, an astonishing revelation emerged. The floor of the South Pole Aitken Basin exhibits an exceptionally high gravity reading. Since increased gravity implies additional mass, it suggests the presence of an enormous and incredibly dense hidden structure beneath the moon's surface. This mass concentration extends deep into the lunar interior, spanning several hundred kilometers below the surface, and its density more closely resembles that of metal than rock. The sheer quantity of this mysterious substance is estimated to be approximately 5 times the size of Hawaii's Big Island, equivalent to roughly 3.5 million cubic kilometers of metal. Furthermore, the heightened gravitational pull is substantial enough to depress the center of the South Pole Aitken crater by an additional 800 meters. Aside from the gravitational anomaly, there are no evident features on the bottom of the crater that could provide insights into its composition. Nevertheless, Russian lunar scientists have formulated a couple of theories regarding the origin of this intriguing signal. Their hypothesis centers on the possibility that the anomalous signal could be emanating from the metallic core of the asteroid responsible for creating the South Pole Aitken crater. According to this theory, when a sufficiently large asteroid impacts a celestial body like the moon, it can initiate a process called differentiation. This is a phenomenon in which the body, whether a planet or an asteroid, experiences melting. causing its constituent materials to separate and form distinct layers. This process mirrors what occurred during Earth's early history. In the case of the Moon, when the impacting asteroid struck, it fragmented into rock fragments, but its dense metallic core, composed mainly of iron and nickel, would have penetrated the Moon's mantle. This would have left behind a metallic core buried within the Moon, encased by a rocky shell. Because the lunar mantle was already partially solidified, the metallic core effectively became trapped within it, and it has remained there to this day. Another interpretation of the additional mass doesn't involve the impact of an asteroid. It suggests that the increased density might be due to a concentration of heavy metal oxides. These oxides tend to form towards the latter stages of mantle solidification. However, these geological processes are not yet well comprehended, and the proximity of this metal concentration to the largest known impact crater in the solar system strongly suggests a connection between the two. Impact sites like the South Pole Aitken Basin offer unique opportunities for scientists to study planetary formation processes. By examining this crater and the underlying metal, researchers aim to gain insights into various aspects, such as the cooling and solidification of the Moon, the differentiation of asteroids, and the timing of early solar system collisions. A key objective is to determine the precise age of the South Pole Aitken Basin's formation, which would enable scientists to establish chronological markers for other solar system events, currently dated only relatively based on factors like overlapping craters. To further investigate this mysterious mass and its origins, scientists are advocating for sample return missions to the Moon's far side. While these missions may not be able to access the massive buried metal directly, they can provide valuable surface material samples. Analyzing these samples can shed light on critical aspects, like the state of the asteroid and the Moon during the impact that formed the South Pole Aitken Basin. Additionally, scientists can identify radioactive elements trapped within the melted rocks, potentially allowing them to determine the precise age of the impact event. By combining these data points and others, researchers hope to unravel the true nature of the hidden mass and ascertain whether it indeed comprises asteroid remnants or if there's another explanation. The Moon's South Pole has become a focal point of scientific interest, characterized by NASA as a region brimming with mystery, science, and intrigue. This fascination has sparked a space race to explore the lunar South Pole, which stands apart from the Apollo landing sites clustered around the equator. India, for instance, successfully landed a robotic probe, Chandrayaan-3, near the Moon's South Pole. Russia also made an attempt with Luna 25, although it ended in a crash. India is now planning a joint mission with Japan called Lunar Polar Exploration, LUPEX, to investigate the shadowed regions or the dark side of the Moon by 2026. One compelling reason for this growing scientific interest in the lunar South Pole is water. Data collected by the Lunar Reconnaissance Orbiter, a NASA spacecraft orbiting the Moon for 14 years, indicates the presence of water ice in certain large, permanently shadowed craters. These craters have the potential to sustain human activities, making them particularly intriguing. Water can exist in solid or vapor form on the Moon because it lacks the gravity to retain an atmosphere. India's Chandrayaan-1 lunar mission was the first to provide evidence of water on the Moon in 2008. The frozen water, shielded from the sun's radiation, likely accumulated in these cold polar regions over millions of years, resulting in ice deposits on or near the lunar surface. This represents a unique sample for scientists to analyze, offering insights into the history of water in our solar system. Researchers can explore fundamental questions such as the origin and timing of lunar water and its implications for the evolution of life on Earth. Simeon Barber, a planetary scientist at the UK's The Open University who collaborates with the European Space Agency, highlights the significance of these investigations in unravelling the mysteries of water within our solar system. There are several practical reasons for exploring and accessing water on or beneath the lunar surface, according to Professor Barber. Many countries are preparing for new human missions to the Moon, and astronauts will require water for drinking and sanitation. Transporting equipment from Earth to the Moon involves overcoming Earth's gravitational pull, and the larger equipment, the more rockets and fuel are needed for a successful lunar landing. Commercial space companies charge approximately $1 million to transport 1 kilogram of payload to the Moon, making lunar ice a cost-effective source of locally available water for astronauts. Water can also be split into hydrogen and oxygen atoms, both of which can be used as rocket propellants. However, scientists need to determine the quantity and forms of lunar ice and assess the feasibility of efficiently extracting and purifying it for safe consumption. Moreover, the lunar South Pole experiences extended periods of constant illumination lasting up to 200 Earth days, making solar power a valuable resource for establishing a lunar base and powering equipment. The lunar South Pole is also located on the rim of a massive impact crater within the solar system, measuring 2,500 kilometers, 1,600 miles in diameter, and reaching depths of up to 8 kilometers. Exploring this region can provide insights into the crater's unique geological features. While some might describe these missions as a race to the lunar South Pole, scientists are cautious about using that term. These missions have been in planning for decades and have faced multiple delays. Instead, the focus is on advancing our understanding of the Moon, as rushing through these missions may not yield the best results, and history has shown that previous space races did not sustain interest in lunar exploration.